Bienvenue à ce petit déjeuner avec des têtes à Papineau. Welcome everyone to Bacon and Eggheads. I am Meg Beckel, President and CEO of the Canadian Museum of Nature, and have the pleasure of welcoming you to today's event. Pour suivre notre événement en français, veuillez utiliser le bouton de traduction simultanée en bas de votre écran. First, let us honor the Indigenous peoples of all the lands that we are on today. Even though we are meeting on a virtual platform, we acknowledge the importance of the land, which we each call home. From coast to coast to coast, we acknowledge the ancestral territory of all the Inuit, Métis, and First Nations peoples. We commit to improving relationships between their nations and ours, and pay respect to the traditional knowledge keepers and their courageous leaders. As always, Bacon and Eggheads is hosted by the Partnership Group for Science and Engineering, a registered nonprofit umbrella organization of 21 science and engineering societies. On behalf of PAGSI, I'd also like to thank the sponsors of Bacon and Eggheads, an esteemed group that the Canadian Museum of Nature is proud to be a part of, as well as the speakers of the House and Senate who have supported this series for more than 2 decades. Just as the past 15 months or so have presented unique challenges for the human species, the global biodiversity crisis is also escalated. The 2020 UN Global Biodiversity Outlook report notes the continued and accelerated rate of ecosystem degradation and the profound consequences for human survival, including increased susceptibility to disease and pandemic outbreak. As we consider our role, the question before us is how can we support positive change to protect our ecosystems? The Canadian Museum of Nature has been involved in studying and cataloging biodiversity since we opened to the public in 1912. With a special focus on the Arctic and species biodiversity research, our 25 research staff run active programs of research and fieldwork every year. The basic research we engage in provides the baseline data that in turn feeds other research on climate change, ecology, and biodiversity. With this in mind, we are thrilled to support virtual events like this to ensure critical topics such as biodiversity remain on the forefront of public policy dialogue. Now, before I hand things over to our Vice President of Research and Collections, Jeff Saarela, who will be moderating today's event, I'd like to quickly introduce our panelists. Lenore Fahrig is Chancellor's Professor of Biology in the Department of Biology at Carleton University. Dr. Fahrig's research focuses on the effects of landscape structures on biodiversity and on the abundance, distribution, and persistence of wildlife populations. Andrew Gonzalez is professor in the Department of Biology at McGill University. He is co-chair of the Group on Earth Observation Biodiversity Observation Networks. Dr. Gonzalez studies the causes and consequences of biodiversity loss and how the impacts of anthropogenic environmental change can be mitigated. Mark Villand is professor in the Department of Biology at the University of Sherbrooke. He investigates how plant individuals, populations, and communities respond to environmental changes, such as climate change and human-mediated disturbances. It's my pleasure now to hand things over to Dr. Jeff Saarela.
Thank you, Meg, and good afternoon, everybody, and thank you for joining us today. Our 3 speakers this afternoon will deliver their presentations in succession, and we welcome your questions during the presentations. Please post them in the Q&A box that you see on the Zoom menu at the bottom of the screen. After the 3 presentations, I will moderate a question and answer session with the speakers. So let's get right into it with our first speaker this afternoon, Dr. Andrew Gonzalez. Andrew.
Thank you, Jeff. Let me just share my screen. I hope you can all see my screen. Hello, everybody. It's a pleasure and an honor to be with you today. Before I start, I would like to acknowledge that Montreal, where I live and work, is on the traditional territory of the Kanen'kehaka. This has long been a site of meeting and exchange between nations. 2020 was a difficult year in many ways. While the pandemic emerged, we learned that the world had failed to achieve its global biodiversity targets set a decade before. This news hit the headlines around the world, as we can see from the pages of Le Monde and The Guardian here. In light of this news, and with the opportunity to build back better after the pandemic, the global community has set about preparing a new global biodiversity framework with new targets for 2030 and a vision for 2050 in which we will be living in harmony with nature. This new global biodiversity framework is now couched on a much richer understanding of the pace and extent of biodiversity change, and also on a richer understanding of what we can and must do to address this critical situation. The reasons for this failure are well known. They are due to the great human pressure that we are imposing on the biosphere. These images give some examples of our human footprint. Each of these can be linked to biodiversity change. Some are well known, such as the relationship between trade and the increase of invasive and alien species. But others are much less well understood, and they have had unplanned, unexpected, and even costly long-term effects on our economy and environmental security. Consider, for example, the increase of extreme climate events, or the growing rates of antibiotic resistance, or the impacts of our pesticides on our insect populations. But what is biodiversity change, and why should we care? Well, biodiversity change is a complex phenomenon. It happens over time, but also over geographic extent. And it represents changes in the variety, abundance, and composition of different facets of biodiversity, including genes, populations, and the communities and ecosystems that species make up, and the functioning of those ecosystems across biomes and on up to the biosphere. We know that this is a natural phenomenon. This change has been happening for millions, if not billions of years, but humans, we know, are now causing biodiversity change, and they're doing so by changing rates of extinction, species introductions and colonizations, and even altering the pace of evolution. It's taking our best biodiversity science to show how humans are changing biodiversity within and across these different facets, and what this implies for our society and economy. So putting this together, we see that we are now bound to nature in a cycle of cause and effect that will only strengthen under business as usual scenarios of our economy. We know that humans have increased its footprint on nature. And a recent assessment by the Intergovernmental Panel on Biodiversity and Ecosystem Services revealed a number of startling statistics. The first of these is that fully 1 million species, or 12% of the known global total, are threatened with extinction, and that 75% of terrestrial and 66% of marine ecosystems are severely altered, while 72% of indicators used by indigenous people and local communities are showing deterioration in nature. All this is occurring while we continue to extract enormous benefits from nature in the form of ecosystem services and goods. Indeed, the World Economic Forum recently estimated that fully 50% of the global GDP depends on healthy ecosystems. But we have failed to adapt our economic system to deal with the externalities these are imposing on nature. And this conclusion is true globally, just as it's true for Canada. Canada's biodiversity is changing rapidly in response to two broad categories of threat. On the one hand, we have climate change. That is the change in the mean and extremes of fluctuations in temperature and precipitation that jointly determine where life can survive and thrive in Canada. And we know that climate change in Canada is going at twice the global rate right now, and is happening heterogeneously across the country. The second set of threats arise from the human footprint. That is the direct pressures that we place on habitats via the land, waterways, and coastlines that we are transforming and developing for urban growth, agriculture, infrastructure for our energy and transport, that together sum up to represent our human footprint. Both causes have a striking geographic pattern to them, and together they're determining the rates and patterns of biodiversity change across the country. This map shows the distribution of the 520 or so species at risk in Canada like this rusty patched bumblebee you see on the right. Not surprisingly, we see that the greatest numbers of species at risk are in the south, and this coincides where the human footprint is strongest. But we're also starting to see the signature of climate change on the distribution of species at risk. Now, the species at risk is an important measure of biodiversity threat, but there are many ways to quantify biodiversity change. This second map shows the proportional change in butterfly species richness across Canada during the 20th century. This study compared recent numbers with historical estimates of butterfly richness, thanks to the Canadian National Collection of Butterflies. Warm colors are showing decreasing proportions of diversity, while green colors show proportional gains during this period. Clearly, Canada is a mosaic of change. This mosaic is reflecting the historical legacy of past changes and impacts and the ongoing effects of our changing climate and human footprint. From these studies, we can make a very clear statement. Canada's biodiversity is undergoing a transformation. Canada's ecosystems are being driven into new species compositions with concurrent effects on ecosystem structure and function, and of course, the many benefits and goods that we get from those ecosystems. A recent projection for the south of Quebec estimated that fully 1/2 of the total protected land area could experience species turnover of more than 80% in the coming century. It's difficult to overstate what this degree of change implies for Canada's ecosystems, our economy, and our environmental security. So how can we deal with this situation? Well, we can redouble our efforts to conserve and protect our ecosystems in the south of the country and the ecosystems of highest integrity in the north of the country. In the south, there are clearly regions of very high priority, as you can see in this map, because of the alignment of the great human footprint and high numbers of species at risk. But we also have to protect our remaining spaces, no matter how small they are in the south. But we need to combine that with cross-ecosystem strategies that protect and restore the connectivity of our remaining ecosystems. Ecological connectivity is the ecological property that allows species to move and adapt to changes like the human footprint and to the climate. My group at McGill and at the Quebec Centre for Biodiversity Science has been working with the Quebec government to plan for connectivity, as you can see on this map for the St. Lawrence Lowlands, a region the size of Switzerland, no less. And we're doing so in a way that anticipates scenarios of climate change and human footprints. Ideally, these approaches should be scaled up to the entire country and done in a way that aligns major initiatives around nature-based solutions. The great uncertainty in our biodiversity future makes prioritization of policy and decisions extremely challenging. Back in 2010, the Ecosystem Status and Trends Report of Canada concluded that we lack the long-term, standardized, spatially complete, and readily accessible monitoring information. And this significantly hinders our capacity to assess the status and health of Canada's ecosystems. But why does this matter? Well, we cannot account for our dependency or achieve a sustainable economy if we don't know where, how, and why biodiversity is changing. We do have a growing store of data produced by many groups and organizations at provincial and regional scales, but this information is geographically limited to the south, as you can see from the numbers of species and occurrences in GBIF, the Global Biodiversity Information System. And in general, this data does not cover our protected areas, as you can see in sky blue here on the map. Investment in a Canada-wide biodiversity observation network would provide us with the capacity to survey, monitor, and better forecast the state of our biodiversity. And this would link us up with a growing global effort for biodiversity observations via GEOBON, the global network whose secretariat recently moved to Montreal. In addition to Canada's biodiversity footprint within our borders, we're also responsible for biodiversity change via our connection to the global economy, the trade and supply chains that link our demand for goods and resources to biodiversity change occurring elsewhere in other nations. In this sense, we are importing biodiversity loss. The supply chains that link your coffee or your lunch to the ecosystems that are thousands of kilometers from here. Those ecosystems may support many species, some of which may be critically endangered. A striking statistic from a recent trade analysis found that Canada's supply chains rank us as the second highest impact per person on terrestrial mean species abundances, That's 4.3 times the global average. We must find solutions all along the supply chain and not just put the onus on the consumer. So let me conclude by saying that we have not yet hit a point of no return. A mass extinction event has not yet happened, but the situation is extremely urgent. We need transformation of how our society and our economy are interacting with nature. We have a decade to respond to the new global biodiversity framework that will be negotiated in China this October. And the focus is on bending the curve of biodiversity by using an integrated set of solutions. I've listed 5 here on the left. None of these alone can make the difference. But if combined into a coherent multi-sector strategy, then we will have a shot, just maybe a shot, of protecting the biologically rich nature that Canadians, when asked, consistently identify as a priority. Thank you very much.
I think that's me. If somebody could just give me a brief heads up that they can hear me and see me okay.
Yes, all good, Mark.
Great, thank you. Well, it's a pleasure and an honor to be able to share with you today some of the work that happens in my research group concerning how particular Canadian ecosystems have changed in recent decades and centuries. I'm going to start by motivating or defining some of the terms that you see here in my title. I study plants. Why do I study plants? Most of what we know about extinction rates comes from an extremely small slice of life on Earth, the vertebrates, things like fish, mammals, and birds. But if you take all the life on Earth and you put it on a scale, more than 80% of what you're going to have there is made up of plants. They're uniquely capable of converting the energy from the sun and inorganic matter into life itself. So if you want to begin understanding life on Earth, you should begin with plants. My title, I also made a distinction between the biodiversity and the composition of the species that we find in different places. Biodiversity is often used as a synonym for sort of all of nature or any attribute we might measure in nature, but as scientists, that's not tremendously useful, and so we mean something more specific. We mean some quantity that represents variety that we find in different places. So if we have in one place wolves and wild turkeys, and in another place we have terriers and chickens, we have the exact same amount of biodiversity. We have 2 species, and we have one representative each of the dog and the bird lineages on the tree of life. If we have a place with only terriers, well, that has less biodiversity because there's only a single species. And if we have terriers and foxes, we have 2 species that are very similar to one another, so we'd still say that we have less biodiversity than we do when we have wolves and wild turkeys. The important point is that for diversity, we can have more of it, we can have less of it, it can go up or it can go down. It's very different when we talk about composition, by which we mean which types are present in a given place. If I have wolves and wild turkeys in one place, the only way I can have the same composition somewhere else is if I have the exact same things there, wolves and wild turkeys. When I have terriers and chickens, I have a different composition. I had just as much biodiversity, but the composition is different. If I have ladybugs and leopard frogs, now I have a composition that's very different because not only is it 2 different species, it's 2 different representatives of different portions of the tree of life. The important point here is that there's no such thing as more or less composition, better or worse, unless we make an explicit value judgment. So whether you prefer wolves and turkeys or terriers and chickens is going to depend completely on whether or not you're managing a national park or whether or not you're managing a farm. What we'd like to do as environmental scientists and ecologists is look forward and see what's going to happen, predict what's going to happen in the future. A very difficult task, but what we can do to help that goal is to look to the past and see how we've gotten to the present day via the various changes that people have made and how nature has responded. We do that in a couple ways in my research group. One is to revisit plots that were surveyed by scientists some decades ago to see how they've changed over time. And another is to look at records of early land surveyors from more than a century ago, specifically with respect to forests, to see how the forests have changed over a much longer period of time. So I'm going to show you a few case studies. The first one comes from southern Vancouver Island, where the dominant environmental driver here has been suburbanization. We can see that where there was lots of natural vegetation 50 some years ago, we now have still some natural vegetation, but lots of people's backyards. And one might expect a change of this nature to cause a decline in diversity, which we hear so much about. But in fact, just the opposite happened. Here we have 3 different habitat types across this landscape, named for the dominant kind of tree that lives there. And in the plots that we surveyed, we actually saw increases in the number of species per plot. We do see lots of change in composition. So if we look specifically at these Douglas fir forests that we studied, of 45 native plant species found in the original study, 5 of them were not found 45 years later when we did the second study. But in fact, dozens of native and non-native species were added to these plots. The disturbances that people have introduced into this landscape or magnified have in fact created opportunities for many different plant species. So overall, what we see is changes in composition, but not clearly declines in diversity, which is the dominant narrative. If we move to the other side of the country, here is Parc National du Mont-Mégantic in southern Quebec, where we can see temperate deciduous forest at low elevation giving way to coniferous forest at high elevation. We have sugar maple turning orange in the autumn here. The factor of interest in this park is climate warming. We have higher average temperatures at low elevation than at high elevation, but with warming over the past 40 to 50 years, the kinds of climatic conditions we see at a given elevation have moved upslope by roughly 150 meters. So the question is whether or not the plant species are tracking that, or their distributions also moving upslope. The answer is yes, those distributions, we can detect them moving upslope, but at a much slower rate than the climatic conditions themselves are moving. So that means that the species or responses are lagging behind warming itself. When we look at diversity itself, what we see is that the number of species in each plot is actually going up, which isn't surprising because there are far more species on Earth adapted to warm conditions than there are adapted to colder conditions. Again, we see changes in composition, but we don't see declines in diversity. The final case study looks even further back in time, and here, based on data painstakingly compiled by Dominique Arsenault and Rimouski from early French surveyors of the landscape, we can compare forest diversity and composition across a much longer period of time. What we see when we do that is declines in certain kinds of trees. So here we see pines. The blue colors indicate declines in their representation in the forests over time. So overall, pines tend to have declined. In contrast, maples, which respond quite favorably to a history of logging, which is the dominant disturbance in this kind of region, have increased quite markedly. When we look at diversity itself, a typical landscape in this region now has a mix of old and young forests, and so we actually see greater diversity of trees across a given landscape today than we saw in the past. Once again, we see changes in composition, but we don't see declines in diversity. So if we look at this overall, what we see in all of these cases are profound ecological changes. Some species lose and others win. So we have declines in things like wolves and pines, whereas many other species have in fact come from elsewhere, or native species have increased in response to the exact same kinds of changes. What we can see is that sometimes biodiversity most definitely does decline. So if you convert pine forests to cornfields, you will find declines in biodiversity, whereas in many other situations like the ones I've shown, you can actually see increases in diversity at different scales. And when we look across the globe at many similar studies, we see much the same kind of thing. These are especially relevant in urban areas. So in urban areas, we have the most visually obvious kinds of environmental changes, and lots of species do not benefit from this kind of change. In fact, cities are far more diverse places than we typically think they are. One question that we're very frequently asked is whether or not this change is bad. And one point I want to make clear in my presentation is that this question of good versus bad is simply not a scientific question. It depends entirely on values that you bring to the table or some explicitly stated objective. Let me explain. So what we do in my lab group and in many others is to study how nature has changed over time and some of the things that people do, like warming up the planet or changing land use, that cause those changes in nature. Now, whether or not you consider a given change good or bad is going to depend entirely on what kind of benefits you're hoping that people will derive from nature itself. So there are many benefits that derive from nature. As Andy was saying, we have regulation of the quality of air and water and the climate, provisioning of food and energy, and social and cultural and psychological benefits of many kinds. So let's look at one specific example to illustrate the point I want to make. One thing that happens in a lot of urban contexts is certain native tree species like sugar maple do not benefit from the kind of environment created when we make cities. Whereas other species, in this case, a non-native Norway maple, do very well. They thrive under the compacted soils and polluted conditions of cities. And so if we're trying, for example, to have a woodlot that ameliorates an urban heat island effect, what you're going to want is dense tree cover and trees that thrive under those conditions, in which case this kind of change might be viewed as good. If, on the other hand, we focus on the cultural attachment people have to sugar maple, and we want to have an urban sugar bush in which we produce the maple syrup, then clearly this kind of change would in fact be bad. But you can't make the judgment until you've decided what it is, what kind of benefits you're hoping to derive. To sum up, people value nature for many different reasons, and it's clear that while nature does change constantly, people's actions have most definitely accelerated some of those changes, but declines in diversity are a very tiny piece of the puzzle, especially in a place like Canada. The challenge is to balance the benefits that we derive from our lands and waters, both in the present and the future, so to not make present day actions that maximize present and short-term benefits that compromise future benefits that we might derive. Science can help achieve goals that are already stated, anticipate future change, but not define what values that we should actually have. And I'll end just by thanking the people who actually do much of the work that I presented here. Thank you very much. On to Lenore.
Okay, well, thank you very much for including me in this discussion. It's really been fun to put this talk together. I decided to spend my 10 minutes talking about some of our work on birds in cities. And because I only have 10 minutes, I'm going to give you the punchlines at the beginning. So first of all, bird diversity, without us even knowing it, increases our satisfaction, our sense of satisfaction with where we live. Secondly, all green space in the city, including all the small residential yards and gardens, increase bird diversity in cities. Third, removing cats won't increase urban bird diversity very much. And fourth, reducing road traffic will increase bird diversity a lot. So I'm just going to spend the rest of the time talking a little bit in a little bit more detail about each of these points. So first of all, bird diversity increases our satisfaction with where we live unconsciously. So this comes from a study that was done by a former graduate student in my lab, Lauren Hepburn. Lauren surveyed over 1,000 residents of Ottawa in sites that we already had information on bird diversity from the Ottawa Bird Count, which covers the city of Ottawa. And Lauren asked people about their feelings about where they lived. Were they satisfied with their area, very satisfied, etc., without telling them that she was actually interested in this question of whether bird diversity was related to their answers. She also she controlled for things like their income and the amount of green space when looking at the relationship. And she found that, in fact, the number of bird species around where we live increases our sense of satisfaction with that unconsciously, so we're unaware of it. So increasing the number of birds from 4 to 20 species doubled the likelihood of a respondent saying they were very satisfied with where they live. And we think it's probably, because of some other research, probably due to the diversity of birdsong actually affecting people's sense of satisfaction. So the remaining 3 points that I want to make are really about, okay, assuming that this is a good thing, going back to Mark's point, satisfaction with where we live, then how can we increase bird diversity or maintain bird diversity in cities? So there are three points here. One is green space. We know from quite a bit of research that green space is very important for increasing bird diversity in cities. And former student Adam Smith, who's actually the person who started up and continues to run the Ottawa Bird Count, he looked at green space, residential green space, and non-residential green space. So residential green space being small bits, the gray areas. So if you look at in this map, so if you look at this map of his sample
points. Those are the bird sample points. And in this, the bird sample point is in the center of each circle. And he looked at the amount of green space surrounding each of those points within 500 meters. And the black part is public green space, large blocks of public green space, and the gray is small bits of residential green space. And he found that these are equally valuable. So to see what that means, if we compare the amount of public green space here on the left with the amount of the total amount of all of the bits of green space on the right, those two sets of green space, the left and the right, have equal value to biodiversity in the city. And this is actually something that we've found in a lot of other contexts, not just cities and not just birds, that if you add up all of the small bits of habitat, they're equal in value to the same amount of habitat in one block. So the second one, if we compare the effects of, for example, increasing bird space to the effects of removing cats, which have had a lot of press associated with them. In fact, we have a study that suggests that removing cats in a relative sense will not increase bird diversity very much. So this was done by a former student, Genevieve Perkins, who again did her study across the city of Ottawa and again used the Ottawa bird count data for her bird surveys. And she surveyed over 1,000 residents as well and found a very small negative effect of cats on birds. And just to give you a kind of an illustration of how small that is relative to some other effects on birds, she found actually a strong negative effect of squirrels on birds. So again, when you control for things like the amount of green space and so on, the birds are, the number of bird species and the abundance of birds is lower in places where you have more squirrels. And squirrels are known to be very voracious predators of, voracious predators of birds. Interestingly, we also found, Jen also found a positive effect of raccoons on birds. We don't really know the reason for this, but we suspect it might be because raccoons are also known to eat squirrels. But just in comparison to the effect of green space and increasing the amount of green space in the city, which will have a big effect on birds, decreasing the number of cats will have only a small effect on birds. Another impact that will have a big effect on birds, though, is reducing road traffic. And we know that there's relationships between road traffic and birds, but the COVID lockdowns provided a really interesting opportunity to actually look at this. So this is work in collaboration with Michael Schrimpf and Nicola Koper, who are at the University of Manitoba. So in this plot, each line is one city of at least 50,000 people across North America, and it represents the drop in urban traffic during the COVID lockdowns last year, based on numbers of cell phone trips. And so if you compare cities, so some cities, I should have mentioned, some cities had a smaller drop in traffic than other cities. Some cities there was a big drop in traffic, and others there was a relatively small drop in traffic, which is related to the increase in the number of birds observed in those cities. So the bigger the drop in traffic, the more birds that were observed during that time period of the lockdowns compared to before the COVID lockdowns. And similarly, if we compare the number of birds in relation to the distance from major roads in cities, before the lockdowns, we had very few birds near large roads, and during lockdowns, the number of birds closer to roads went up. So there is an increase in the number of birds close to major roads. So again, the effect of road traffic and reducing road traffic, that is something that we can do if we're actually interested in this benefit of birds to our sense of satisfaction, and maintaining and increasing it, then reducing road traffic is something that will really help with that. Oh yes, this is just to show you on these are all the species, 100 or so species in these cities. And just to show you that this effect was consistent, quite consistent across almost all of the species. So all the purple here represents evidence, some kind of evidence of more birds of that species in response to lower traffic during the lockdowns. Okay, so I just want to go back and remind you of the other punchlines, because by now you've probably forgotten them. So first, unconsciously, bird diversity increases our satisfaction with where we live. And so if that is a good thing and we'd like to maintain or increase bird diversity in cities, then we need to focus on green space, and all green space matters, not just public green space, but also all the small bits of green space. Removing cats will have a little effect, but not much, and reducing road traffic will have a big effect. Thank you.
It's now my great pleasure to invite Carol Hughes, the Assistant Deputy Speaker and Deputy Chair of Committees of the Whole, to offer our thanks to today's panelists. Carol. Yeah, Carol, you're on mute.
Excuse.
Perfect.
Alors, écoute, premièrement, j'aimerais faire une petite déclaration que je suis sur le territoire des Algonquins, Anishinaabeg. Je suis ici à Ottawa. Je remercie les Têtes à Papineau d'avoir mis un thème assez important d'avance, et c'est évident que ça joue un rôle très important et que les gens doivent reconnaître les liens entre le climat, le changement des climatiques, l'environnement et les emprunts humains. Je vais changer à la version anglaise. Sorry. Somewhere here. Okay. Alors, so thank you very much to the presenters, Lenore, Andrew, and Mark. The information was quite helpful, and it was evident by the amount of questions that people were very engaged and quite interested in what is happening. I can tell you in the riding of Algoma, Manitoulin, and Kapuskasing, I have Mishpekauton First Nation with a group of environmentalists that have been working very hard in trying to save the Lake Superior caribou. And we know how much the wolf population has dined on the Lake Superior caribou in that small population that was on Mishpekauton Island. So there is some efforts that have been done there, but that need to continue to be done there. I really appreciate the information about the green space. Not too long ago, the Health and Research Caucus also had presentations that were done on the importance of the green space when it comes to mental health. And I know that with the diversity or the biodiversity and animals and birds, how important that is as well to the well-being of individuals and their mental health as well. So I obviously appreciate, and there's so much that you have touched on that is so relevant to the health and well-being of our planet and of individuals, and want to thank you for the presentations that you have made today that has certainly assisted in encouraging more conversation and more action on that front. And so on behalf of the Bacon and Eggheads and their partners and parliamentarians, I do want to thank you for your presentations and for taking the time to enlighten us.
Merci beaucoup. Thank you very much.
Thank you. Thank you for these insights, Assistant Deputy Speaker Hughes, and for the continuing support we've received from the speakers of the House and the Senate. On behalf of the Bacon and Eggheads Committee and the Partnership Group for Science and Engineering, I want to sincerely thank the Museum of Nature and all of our generous supporters and sponsors for helping us run these events. I'd also like to thank our moderator and all our panelists for this kind of bird's eye view, bird's eye and beyond view of the state of biodiversity in our Canadian backyards. So this is the last event of the Bacon and Egghead season. We'd like to wish everyone a relaxing and safe summer season and look forward to seeing everyone's return in the fall. To stay up to date about our upcoming events, we encourage you to follow us on Twitter at Ottawa Eggheads, or connect to the Partnership Group of Science and, for Science and Engineering in LinkedIn. Thank you to everyone for joining us today. Merci d'avoir participé à cet événement grandiose. Bye-bye.
Merci, bye-bye.
Merci, au revoir, bye-bye.
Merci, au revoir.
Merci tout le monde. Thank you very much.